afternoon, everybody, and welcome to our webinar on freight technologies for sustainable and attractive European freight. Thank you very much for joining us this afternoon. This webinar is based on the final event of Freight Hub project. It is a research and innovation project within the framework of the innovation programs on freight within Shift2Rail. I think it's a very good opportunity to see what are the kind of research and innovation actions we're taking on board within Shift2Rail for freight. It covers most of the things we are dealing with in AP5, although in this final event, in certain things that maybe they are not represented in Freight Hub, we will give just a bit of a flavor or a taste of other things that are happening, but not in this project. I haven't introduced myself properly, so I am the IP5 for the Freight Innovation Program Manager. I am lucky enough to work with this very good bunch of people, and which I think are delivering very good results and making very good progress that I'm sure at a given point is going to have a big impact within our freight rail community, and it's going to be a cornerstone for the Green Deal and foster this model shift so we can cooperate with road traffic and transport more goods through the rails, and we can make all our European communication network more effective. So I now pass over the word and I pass the floor to Anna, who is going to introduce you to the webinar. I wish and I hope you're going to have a fantastic afternoon talking about trains, which is always very enjoyable. Anna, yours the floor.
Thank you, Manuel, for the introduction. And my name is Anna Björkman, and I'm working at Closer, a link third party to Trafikverket. And with me, I have Anders Ekmark and also Jan Bergstrand from Trafikverket. And together we are the coordinating team of Freight Hub. And yeah, I will moderate and guide you through this session. But first, let's have a look at the agenda. And we will start with some overview and also look at an introduction video, so you get a hint of what Freight Hub is about. And afterwards, we will hear some presentation about the freight customer needs and contribution of Shift2Rail innovations, and also listen to condition-based maintenance presentation, intelligent video gate, and real-time network management presentation. But let's start with the introduction video.
European freight transport is one of the most competitive markets in the world. The main objective of the Freight Hub project is the development of functional requirements for a sustainable and attractive European rail freight. This, in combination with other S2R IP5 projects, will lead to a 10% reduction in the cost of freight transport measured in tons per kilometre, a 20% reduction in the time variations during dwelling, an increase in the attractiveness of logistic chains by making 100% of the rail freight transport information available to logistic chain information systems. Freight Hub creates solutions to increase the competitiveness of freight transport by rail, the most climate-smart and resilient transport mode. The development of road transport is moving fast with, for example, platooning and advanced driver support. For rail to access highly processed goods, the business analytics in Freight Hub show that the rail industry needs even more innovations. Together, the S2R IP5 team develops technologies for sustainable and attractive European rail freight. Freight Hub activities and the application of the following IP5 S2R solutions in the market fully fit under the European Union priorities of greening the transport system, where rail freight plays a pivotal role. Integrated solutions focusing on digitalization enable rail automation. The solutions will maximize service quality, productivity, resource utilization, and network capacity. A key enabler is the pan-European rail freight. Asset control tower and customer communications boost the productivity and punctuality that contributes to competitive cost structures, stimulating growth in Europe. Technical solutions such as digital automatic coupling and telematics enables positioning and sensor data. It contributes to competitive strength with increased flexibility, longer and heavier trains for growth on European corridors. New concept for freight wagons with innovative running gear that is track and noise friendly gives benefits for society and customers. The intelligent wagons and the smart freight assets also contribute to the cost efficiency in maintenance and operations. Freight Hub has also developed methods and tools for condition-based maintenance of locomotives and wagons. Modified IT systems with all required parameters compare actual values and thresholds in order to deduct maintenance tasks. The common force in IP5 is also to work with driver assistance, hybridization, and advanced propulsion technologies, significantly reducing energy consumption and emissions. Freight Hub contributes to the development of a reliable, efficient, and competitive rail freight system with a high-level definition and architecture. With the possibilities from digitalization and automation, the entire production chain is connected, climate smart, and self-governing. An important building block that could facilitate the path to this future vision is automatic coupling. The automatic coupler creates the opportunity to provide the wagon with electrical and data connections that enable functions such as electro-pneumatic brakes and a number of other digital innovations. In addition to the actual interconnection of freight wagons, several necessary tasks are currently performed manually. They can now be completed automatically. Implementing automatic coupling and complementary digital solutions will radically improve rail freight traffic in terms of capacity, punctuality, efficiency, and profitability. Another IP5 innovation is the Intelligent Video Gate, or IVG. With the help of cameras, sensors, and RFID technology, IVG collects data on the freight wagons that operate the railway and processes the data in real time. The technology enables, amongst others, automatic registration of wagons and units. Collected data is used for terminal planning and control of loading and unloading. The solution provides cost-efficient and quality-based handling of freight traffic and makes terminal work more time-efficient. For hubs, terminals, and courtyards, IP5 develops digital solutions and improves data collection for control, operation, and coordination. Integrated with terminal design, the solutions enable efficient freight transport. With research and innovation, together with the possibilities of digitalization and automation, where the entire production chain is connected, smart, and self-governing, Freight Hub, together with IP5, develops sustainable freight transport by rail for our customers, society, and future generations.
Yes, hello again. I'm Jan, as Anna mentioned. I will try to put Freight Hub, the project, which has now come to the part where it's a final conference, and we will try to, out of this movie that proves IP5 as such, but in general also Freight Hub issues. We have come to the final conference with tangible results, and we will look at it. But we paved out a vision very early in IP5, where Freight Hub and other project was belonging to, of course. And we follow this very strictly. And it's all about digitalization enabling a larger part of automated processes. It can be automation on lines with driverless trains, but also in the nodes, yards, and we also use it for as a more intelligent asset, locos and wagons. And we need, of course, with more intelligence, brought along on the assets, some kind of surveillance in control towers, etc. So it's also connected very well to steering and operational control. So this is the vision that we work all over with. So yes, I leave to you, Anna.
Yes, and this picture shows the technologies that are developed within the Innovation Program 5. And the Freight Hub was one of the earliest projects within IP5, and started already in 2017. And as they already mentioned, it's about to finish. And within Freight Hub, we have looked into real-time yard and traffic management, and also technologies, sensor developing for predictive maintenance of wagon bogies, and we also looked into how information flows can be improved with the concept of intelligent video gate, and we looked into future wagon concepts, both for current wagons at terminals and how they can become more environmentally friendly, but also new wagon concepts and how they can be energy efficient in the future. And so Freight Hub has been focusing a lot on the technology development, but it has also looked into strategies on how to introduce these technologies to the market. So within Freight Hub, we have these different work packages, and we will look a bit deeper into some of them during the session. But first, I will let Anders and Jan tell you a bit about the migration plan and also about the Freight Look of the Future. So Anders, if you want to tell us a bit about the Freight Look of the Future.
Yes, I will. We have the locomotive of the future is an important part in IP5, and in Freight Hub I worked with for once the last mile propulsion system, and upon the requirement from the customer needs and analysis, a design has been made and a prototype has been built for this, and will be further on tested in later projects. We also have taken care of two subsystems. It's one is a battery management system, the other is a control monitoring unit, and both them together has proven that you could reduce the energy needed with about 23%, and that's a lot of very good effect. And the design has been made in the project, and the prototypes will be built in Freight Rail 3, a project that started last year. Power peak shaving is an important object that if you can cut the peaks, you can reduce the need for the infrastructure management to come up with the electricity on the line and so forth. And it could be solved either by the infrastructure or by the rolling stock. And these two has been analyzed, and they're seeing that there's a lot of possibilities here, but it also requires a lot more of automation and activities that could synchronize the effects better. Yes, back to Jan.
Yes, migration planning is an important thing. We have a block with business analysis, KPIs for freight, and migration. And migration is a key for success. And very often, sadly enough, we forget about it. We have good ideas, but we don't bring them together in one piece, so to speak, in one system. That means we loses effects, we loses payoff possibilities. So that's something to really improve. And we have in this project looked into the innovations in a organized way and a logic way, so that the picture shown here is about the elements we have been working with in not only Freight Hub, but all over IP5. And you can see that a lot of other innovation fields is connecting, and they are also connecting towards each other horizontally. And it's also a matter of timing to do things in the right order. And if you can merge this, it will of course give great effects. One typical such example is the digital automated coupling, one very big topic nowadays. And it's an enabler, a buzz between assets that brings along data cables. Data management is possible. It brings along electricity, making it possible to, with energy supply for sensors, etc. And air, of course. But the other solutions with sensors, etc., gives, of course, a higher degree of logistical advantages. You can come into the topic Mr. Norbert Carl will present with condition-based maintenance. You can also use it for logistical reasons, knowing where the equipment are situated and also the freight, the goods itself. So this is a typical example where you have to combine innovations to make a good payoff.
Okay, thank you, Jan, and thank you, Anders. And I hope you have got a good overview of Freight Hub. And before we go a bit deeper into some of the work packages, I will let Dr. Jürgen Ernst from Deutsche Bahn talk a little about his study about the freight customer needs and how they can how the Shift2Rail innovations can contribute to the needs. Please, Jürgen.
So welcome everybody, and I'm Jürgen Ernst from Deutsche Bahn, and I like to say a few words on the study on customer needs, and we carried this work out within the cross-cutting activities of Shift2Rail. And as you all know, the main goal of Shift2Rail is the funding of innovations that improve the railway system in order to attract more passengers and transport more goods in relation to other means of transport. We call it Shift2Rail. Therefore, knowledge is required on the customer needs or the transport decision criteria of the customers, the importance and ranking of the criteria, and the actual performance of the railway system. And last but not least, the identification of the main obstacles. And we are going to evaluate the contribution of the Shift2Rail innovations to the customer needs and removing of obstacles. And first of all, we evaluated the criteria for transport decision. And we have 4 categories. First of all, the basic requirements, and they have to be fulfilled to consider railborne traffic at all, e.g. sufficient transport distance, we have a terminal nearby, or uninterrupted cooling for reefer transport. Otherwise, people will not use rail and the goods are transported by on the road. Then we have the direct criteria. They have a direct impact on the transport decision of the customer. It's price, reliability, transport time, flexibility, etc. And these criteria are determined by the transport technology and process. And then there we have the service elements, and they are determined by the performance of the service provider. For example, load tracking, competence of service provider. And last not least, there are the boundary conditions. They are mainly influenced by political measures, for example, the track charges. And the Shift2Rail innovations, they have a strong impact on the direct criteria and the service elements. And I will talk about that a little bit more in the next slides. First of all, to the methodology for ranking of the decision criteria. And the ranking is carried out with respect to today's performance, the future importance, the future importance, and in red, the actual performance. And the customer survey was carried out by means of personal interviews with 11 rail-affine customers for the core market and 7 customers with low-density, high-value goods. It's the extended market. It's the market that is not covered by rail today, but there is a high growth, and it's very important to get these customers. And all the customers we interviewed are international operating companies with transport demands across Europe. And here's the result of the customer survey. Here in the blue, you see the actual importance of the criteria. The criteria are here, and in blue, the actual performance, and in green, the future importance here. And you see that all these criteria are very important. Usually you think only about the price, but the quality is even more important, and other criteria as well. But if you look at the red line, that it's the actual performance of the rail system, and there you see a large difference. And where there are large differences, we have to do a lot to attract more goods on the rail. And these are the main obstacles we have to care about. The flexibility, we have to be more flexible. We have to introduce tracking and tracing. If you have postal orders, it's usually you know where your package is, but not on the rail. Rail is too complicated. We have to simplify it. And the reliability and punctuality has to be improved. Speed has to be improved. Rails go about 20 kilometers an hour through Europe, and that's not compatible to road transport. Price is important, but you see not only price, all the other parts are important. And last not least, we looked at the contribution of Shift2Rail innovations. And there we have seen that the most important innovations with respect to customer needs is the digitalization of the organizational freight process. And it's supported by the following Shift2Rail innovations. It's real-time network management and yard management. Advanced freight operation. It's not part of IP5, it's cross-cutting activity. It's very important to digitalize the freight processes. And the conceptual data model, the data have to be exchanged between all the stakeholders. And the digitalization of the processes contribute to the customer needs, to the reliability, to transport time, to flexibility, tracing, and simplicity. So they contribute to a lot of customer needs. But the digitalization of the organizational processes requires the digitalization of the technical freight process and assets. And this is carried out by Shift2Rail innovations of IP5. Jan mentioned them already. The digital automatic coupling, intelligent video gate, digitalization of wagons, and last not least, the last mile propulsion. But the impact of the customer needs is only achieved when a lot of innovations are realized together, what Jan mentioned, where therefore it's important to develop the migration plan. I come to the conclusion. In our work in cross-cutting, the freight customer needs are identified and ranked. And most of Shift2Rail directly or indirectly contribute to the improving of the customer needs. That's a great job the people in IP5 carry out. But there are still further fields that need to be addressed. For example, activities focusing on an improved customer interface and easier market access, and making rail-bound freight transport trains as easy as transport on the road. And that's important topics that have to be carried out within the next project. Thank you for your attention.
Thank you, Jürgen. Very interesting presentation. And we will now move on and go a bit deeper into some of the work packages, at least the subjects of the work packages within the Freight Hub project. It's condition-based maintenance, intelligent video gate, and yard and network management. And we will start with the condition-based maintenance, and I will let Norbert Karl from DB Cargo, he's also the IP5 coordinator, guide you through the presentation. Thank you.
Thank you, Anna. Thank you. I hope you can hear me very well. Wonderful. So yes, 3 topics. Condition-based maintenance will make the start. Yeah, just as Anna said, so I'm responsible for digitization automation at DB Cargo and have been part of this IP5 journey from the very beginning. And I must say, Freight Hub is a very good group of people. And the film has shown that it's a round package of a number of topics. Of course, CBM, condition-based maintenance, we call it CBM, is part of this consortium as well. Now, if we can dive in, I think I'm not able to control the screen, but yes, I do. We see first that we are in a journey here. So basically, CBM is not something static. You've seen it as an element of our vision, but there are multiple facets to condition-based maintenance. You see on the left-hand side that we need to collect data. Yeah, so that's the origin of the whole process. We collect this data from locomotives and from wagons. And then under the 4th point, you also see digital diagnostics, which should a little bit resemble a video gate. So you can also collect data from certain infrastructure elements. And all of that flows together in a process in big data analytics. We call it the Asset Intelligence Center. And in the vision, you've seen it in the form of a tower, the Asset Control Tower, which is then meant to steer the processes of our fleet, to optimize according to life cycle costs, so that we don't go to maintenance too early, but that we avoid failures in the field. So that's the whole purpose, and therefore we need to get the maximum out of this data. That's what CBM stands for. And of course, there are a number of operational processes that may follow in maintenance, but you could also say okay, it's not just condition-based maintenance, there's also an opportunity for condition-based operation. So there are future steps, and we're showing how this is embedded now in IP5. So we see 4 steps. Step 0, equalized maintenance, which means spreading maintenance measures. So today maintenance is time-based and runtime based. So for every component, our rulebook says, okay, after a certain time or a certain mileage, you have to replace it. You can experiment with these rules and stretch the intervals. So that's what step 1 is about. Step 0 is about. Step 1 is condition monitoring, and that's right where we're here with Freight Hub. We're looking at certain conditions and certain components. I come to that later. But yes, you need to understand the behavior of your component, and you can do that by various means. In the end, of course, sensors, telematics play a role. And then you continuously monitor. And the step 2 involves that you have algorithms in place that can already sort of follow the behaviors and can be checked for step 3, then to predict the future state of component conditions. So that's the whole journey. There's a lot of data cleansing, data management in that process. And you see that we have actually 5 consortia which are involved in this 4-step model. Now, if we look at condition-based maintenance from another perspective, we must say, okay, it's also about architecture a lot. How do these elements, sensors, and telematics work together? Is there some sort of a IT layer that we need to consider? And we've had the discussion at IP5 level globally with all the partners, and came up with some nice results showing that you need to consider the whole data management chain from data collection to data processing, but you need some sort of a rule engine too, and you have to look at different applications in a railway undertaking. And of course, you could draw this architecture larger. It's not something that's static for us, but it's something we always constantly discuss when we talk about CBM in these different steps that we're facing. And this, I like this picture very much, although there's not so much nitty-gritty content, but it shows really that that we've launched this rocket. I must say CBM is a big part of IP5, and with every new consortium, we're building on top of the success of the previous one. So Freight Rail has started the whole project. Now we're talking about Freight Rail 3 and 4. Freight Hub was the 2nd year, and here we had a particular focus. But if we look at the results, if you look at the satellite, you see a lot of results have been created, which actually will mean mean first business value. So we started with some signal reports and some dashboards based on just one class of locomotive, just in one country. But now we're extending this to Europe and with new functionalities that we experiment with. And it's always this finding out what does the data mean for me, what's in it, what dashboards can I build, where can I be faster in my processes. Now I come to the particular scope of this topic in Freight Hub. So in the work package 2, we looked at wagon bogies, and we said, okay, we need to have a look at wagons. And of course, wagons are different. Every wagon is different, but what's the same for most of them is the Y25 bogie. And we analyzed these bogies. So, well, first a sensor specification already tackled the bogie. That was the step 1. Then we looked at failures. So what are the cost and availability drivers for wagon bogies? And we identified the spring as one of those. And then the challenge was to develop ad hoc algorithms to understand the behavior of the spring, something that SITE has been driving. But basically, we said, okay, before we go into the digital world, let's look at hardware, and let's look at what we can learn from the hardware about the behavior. So laboratory testing was done about in order to understand why certain cracks, certain failures in springs were happening. Yeah, so before this project, we really didn't know much about the condition of springs, and we couldn't really forecast a lot and predict a lot about it. But this has been a good step forward in order to understand this component. Of course, in the end, there's a lot you see about synchronization, filtering of the data, and then the processing. We wanted to do field tests as well. But yes, before we get to that point, let me just show how it was set up. Yes, with two deliverables, the definition of scenarios and the design of the system. I don't want to go into much depth here, but it's always challenging to find the right partners and to find the right team around such a task. And I think DB and Site formed a great team. That's what I can highlight here in order to continue this journey. And one of the great challenges was also to absorb all the progress that was made in other projects. So meanwhile, we were working here on this topic. There was, you see the start of the journey, a whole maintenance strategy developed around CBM, list of components and feedings, all of the topics, thresholds defined in Freight Rail. Then in Freight Rail 2, the focus was on diesel locomotives. So also there are some learnings. And Freight Rail 3, finally, the application of a number of use cases that had been defined in Freight Rail 1 and 2, checking those use cases for application in other European countries. And now we're already looking, you must know, at a cluster of 1,400 locomotives that are in our analytics cluster. And so there's quite an amount of data coming in. Exciting for Freight Hub, but the wagon is not intelligent yet. You must remember that. So back to the springs. What was done, we sent our springs to sites, a number of DB springs, and they have been checked thoroughly, tested with all sorts of pressure tests, measurements, in the end destruction tests, in order to understand what's actually happening here, how's wear and tear happening. And we could see that from the exterior measurements, you could conclude almost correctly to the actual condition of the interior material. So the material behavior can be measured. And Site then went on and said, okay, we need to define a device that can do this external measurement. And they did that, and we wanted to test it. And what came next was, unfortunately, COVID. So the actual device developed in this project did not get tested. However, we were looking for workarounds, and we discussed the situation intensely. And what we managed to do was use some of these developments that happened in parallel. What happened in parallel was our fleet of more than 50,000 wagons have been equipped with sensors. Yeah, so Wagon Intelligence, a big project at DB, has equipped some 53,000 wagons up to date. And these sensors include a weighing sensor for loading, unloading. And so the change of plan here was, oh, okay, we don't need to measure acceleration as we originally planned in the setup of Site, but how about we just use the data from this sensor that gives us the spring length to determine if it's loaded or unloaded, and we go in depth in the analysis of this data, and it has actually brought us the progress we needed. At least we're in the process of confirming that. So right now the results are being compared to the lab test results. And what's happened then is, of course, once you know about the condition of the component, then you need to sort of express that in a workable manner, and that's where the dashboard development comes in. So also this is a final part, and in this project, a colleague of mine has developed some SAP dashboards here, which are really usable, which are practical. So there is a concrete result which we would not have without this Freight Hub project. And yeah, so on this note, we can really say what was meant to just start the journey was really brought really a business benefit here, which is great. On the other hand, it brought some insights. If we look at my last slide, basically the challenge that we still face on the wagon side, the difficulty of data generation is evident. Yeah, no power availability. You cannot do much in the live environment, and there's no historic data too. The challenge of electrification has to be overcome urgently. Yeah, we talked about couplers before, so something we definitely need in the future. We must say the CBM journey is still strongly driven by locomotives, but definitely CBM wagons will follow, and that's also supported by other projects. We see that synergies between these exciting and multiplying use cases in the digital world are possible. Like I said, with the weighing sensor that we can now use for the component monitoring. And so that's always important to check for synergies and discuss the topic based on use cases and not create an island where you just have your individual scope. But definitely, to conclude, we must say for continuous online monitoring, further developments will be necessary. And that's also where we must say, okay, Freight Hub just did a small step in the right direction, and now there will be other projects to follow. That's so much about CBM from my side, and I would hand back to Anna unless there are any questions. Feel free. I will try to answer.
Thank you, Norbert. A very good presentation. And I've seen that some of you have written a few questions in the Q&A. Please feel free to do so. And we will try to take one question now, but we will take more perhaps in the end if we have time. So Anders, do you have a question?
Yes, hello Norbert. I have one question that you can give me a short answer on because of the time. Which is the further development that we will do in this field, and what is the expected impact?
He's muted.
Norbert, can you unmute yourself again?
That was the short answer. Yes, sorry, definitely. Okay, let me be short and precise. We will go on with CBM. It will be a suite of dashboards and analytics that we can use for all assets in the fleet. And the true value of that is definitely life cycle cost reduction, but we must also be clear, we want to use data that we generate here for future operations and for the better of product development.
Okay. Okay, thank you, Anders. And we will take more questions in the end, as I said. But let's move on to the next very interesting presentation about the intelligent video gate concept by Besad Kornyad from KTH, a third link party to Trafikverket. The floor is yours.
Thank you, Anna. Good afternoon, ladies and gentlemen. I hope you can hear me well. My name is Besad Kornyad, and I'm a researcher at KTH, Royal Institute of Technology, Stockholm, Sweden. And I'm going to talk about Freight Hub VP4 Intelligent Video Gate, or the IVG, as we also call it. So the project was concluded actually last year for our part and has continued within the framework of FreightRail 3, which we also called IVG, or informally DemoGate. So I'm leading or assisting Trafikverket with the leadership of this VP together with Mats Åkerfeldt at the Swedish Transport Administration. So let's see if we can change slides. Yes. So these are the partners included in this work. DB has been leading the first part of the project, that is in Freight Hub, and as I said, Trafikverket is doing it now in FreightRail 3, together with LinkedIn third parties, that is KTH being one of them, and also research institutes RISE, TFK. We have an RFID expert at Learning Well, and also Ericsson is involved. Apart from that, we have Hitachi Rail, having mostly to deal with physical installation and selection of hardware. That's their part mainly in the project. and also the system supplier from Spain, Indra, who are basically mainly working with image processing and the software side of this concept. Yes. So, as I said, we started in 2017, and at InnoTrans 2018, we showcased, we had an exhibition of this, our thinking and the concept there on a model train platform. So I thought it could be a good idea to start off with showing this video we made in conjunction to this exhibition. So if you could please start the video. Okay, thank you very much. I hope you enjoyed the video and the accompanied music, and that you got an overall view on the concept that we have in mind. So this figure tries to illustrate that, the overall information that you could get from such a gate. Wagon code, the sequence on a train, loading units and sequence, and any deviations could be detected from pre-advised lists. You could then detect numbers, codes, dangerous goods placards as we saw in the video, and damage detection. So these kind of information could be used for different aspects on the terminals, which we mainly focused on in Freight Hub, but also in Freight Rail 3, we are looking at yards. We have, this enables automized and digitalized processes, handling deviation, as I said, mainly at check-ins and checkouts, improve data quality, optimize transshipment plans, and better interface towards road hauliers, more precise departure times, ETAs. So this could be used also for an overall increase in operational efficiency and sharing of logistical data. So yes. Yes, our partners, as I explained before, they have different expertise, and we are using this in this project. Indra has worked a lot with electronic toll systems and has a great know-how in that. So that's their part, you could say. And as for Hitachi, previously on Saldo, they had worked with a system called train conformity check system in order to see if the loading units, for instance, are positioned correctly on a wagon. Could be a semi-trailer kingpin that is not connected correctly, or you can check these kind of things. So we're using that expertise. And RFID, consisting of RFID tags and readers, is something that we have incorporated in this, and we had an expert from Learning Well, as I mentioned. And this has come quite far regarding the readers in the infrastructure. For instance, in Sweden, we have multiple readers, and I know the development is going forward also the rest of the Europe, and more wagons are tagged with RFID tags. So then there's a question of standardization of which kind of tags and readers are used. So there's a discussion there. But in our case, as I said, we want to have this more of as a complementary system to the OCR. Yes. So the basic technologies, which I think you know by now, is image processing, reading plates and codes, mainly on wagons and on locomotives, as well as on intermodal loading units. And the RFID tag and reader is a complementary system for the wagons mainly. And also locomotives, you could say. But the intermodal loading units, this is, we'll look at that from later on, I guess, but this has not come that far as wagons with being tagged. Okay, so we have also thought about and analyzed the information exchange, both from the supply chain perspective. We have, for instance, Ericsson involved in their concept, which we have tried to apply here, Internet of Logistics, and they have experience of air freight industry. So this is something we have looked at, how applicable that is in this setting. Also, we have tried to consider, or we have considered, the Shift2Rail integration layer more for a transport chain perspective of the information exchange, connecting terminal operating system with other type of systems. Okay. So from a terminal perspective, having digitalized, pre-advised information, you could do a better planning with this kind of tools. For instance, regarding crane movements, these could be optimized, and also the interface road hauliers. could be improved. Yes, we have made detailed sketches and calculation on the physical installation. Here you see a figure of a single track solution and where the positioning of the cameras and the readers could be. We had made an equivalent sketch for a double track solution. Yes, and now in this continuation in the framework of FreightRail 3, we are actually building demonstration gates. We have a detailed solution in place for Port of Gothenburg in Sweden, in connection to the Port of Gothenburg, you could say, where we have the agreements in place, sketches in place, and hopefully we can get the foundation in place before this harsh Swedish winter kicks in, and the full demonstration gate can be in place during the spring next year. As for our German partners, DB have shifted a little bit focus here from terminals to yards, and they have come a long way, having gates in many yards now, or several yards at least in Germany. However, we have chosen this one in Nuremberg as the part of the demonstration here in FreightRail 3. Yes, so we have looked on synergies, some differences between yards and terminals until now. Okay. For you who want to know more, we have published, apart from the deliverables that are, some of them are public, we have also published some papers at TRA this year. You can find them digitally, although the conference was canceled. So one paper dealt with the overall concept of IBG and how to apply these emerging technologies, whereas the other paper went into detail about the information exchange and the Internet of Logistics. Okay. So with that, I would like to conclude my presentation and thank you for your attention. If you have any further questions or queries, just contact me at the email there you see there.
Thank you, Besad. And it's very nice to see how the work that started in Freight Hub has continued in other Shift2Rail projects. And I believe we have time for a question. Anders?
Yes, hello, Besad. I have maybe a difficult question, but I still like a short answer as usually. If you look at the intelligent video gate at the system level, what can you see the expected impact on the system?
Thank you very much, Anders. I will try to be as short as possible here, but at the system level, I would say, well, you can improve the system information exchange along the supply chain and the transport chain. Well, as looking at the operationally, it's mainly digitalized processes and the automation that it could enable. That's the main benefit. And just to mention what we are working on here, we're looking at AI for image processing at the next step, and also for handling data exploitation and sharing in the best way.
Okay, thank you, Besad. And we will move on and listen to a presentation about the yard and network management instead. And we welcome Magnus Wahlborg from Trafikverket. Magnus, the floor is yours.
Thank you, Anna. Yes, I will talk about yard and network management and also about our results in Freight Hub WP3. So next, please. So for yard and network management, we started 2016 with ARC and SMART projects. And then in 2017, a member called Freight Hub and OptiYard working in parallel. And after that, we proceeded with Freight Rail 2 and Freight Rail 3. And for yard and network management, we have working to have regular seminars during 2017 to 2019 September. And Trafikverket is leading this part together with the DB, and we also have involved the Green Cargo. And from system supplier, DXC, big American with the German part, and then Indra, system supplier Spain, and Simcon, small system supplier Slovakia. We have had a wide academia, 6 research partners in Sweden, France, Université Gustave Eiffel, University of Rome, Italy, and DLR, Germany. And for yards, we have looked at Sweden, Germany, Czech, and Italy, where we have this closer cooperation. And in, so next, please. This concept is developed by Freight Hub in cooperation with OptiYard. And what we have is a sending yard communicating with the network, and then we have a receiving yard. And we're having a link for this in for common communication. Next, please. For having this link, we also come into this with the yard rules. So we have infrastructure manager responsible for the network. We're coming to the yard manager and or terminal manager. We also come into involving the freight train operators and in some aspect also freight customers. Next, please. The freight traffic in Europe and in Sweden, a big share of freight traffic runs before timetable. In Sweden, about 15% is plus minus 3 minutes, and about 45% is plus minus 15 minutes for this Malmö-Hallsberg. And there is a potential to improve traffic control and a potential for better decision support. Next, please. This is the Swedish part of the demonstrations. In ARC, we focus on Hallsberg and Hallsberg-Malmö. In Freight Hub, we have more coming into Malmö. And Malmö, as you will see soon, is much more of a bottleneck compared to Hallsberg. And then we proceed with Freight Rail 2 and Freight Rail 3, and there we also widen our perspective. Please, next. This is the yard of Hallsberg, and to the left you have the arrival part, and then in the middle the marshalling part, and then to the right the departure part. And here we are looking at the red part, Trafikverket, and how we communicate with the yard manager, that is Green Cargo, for this yard. Next, please. This is Malmö, and as I said, Malmö compared to Hallsberg is much more of a bottleneck. Here we have a common arrival and departure yard, and that you can see in a red dotted. And then we have a marshalling part, and that is blue. And then we have a combi terminal, Mert, and that is to the south west of this picture. Here we are in Freight Rail 2 and Freight Rail 3. We are developing this communication platform and decision support. And in spring of this year, we have set up requirements and done that in cooperation with the Trafikverket dispatchers of Malmö. During this autumn, we develop a pilot and involve the yard manager, Green Cargo, and also start a dialogue with RU Freight and Combi Terminal. And then in the next year, we will improve pilot, do demonstration, and do evaluation of Malmö. Next, please. This shows to the left is 12 problems of the yards, and this is problems identified when we studied Hallsberg. And to the right is with improved digitalization and improved information, and how this improved information can reduce or solve identified problems. And our analysis of this was this with cooperating planning platform and data sharing as the most efficient or low-hanging fruit. So that's also now what we are doing in Malmö. Next, please. Now I come into what we have done in Freight Hub. So to the up number is number 1, and that is the work in made by DLR, responsible with the faster freight trains concept, and also doing validation for a corridor in Germany, Karlsruhe, Basel. I will come back on that later on. And then in the middle, we have developed a demonstrator with KTH, developed a 2-step optimization, and developed a timetable viewer of the Indra system supplier, and also a connection to Railsys. And to the lower left, Linköping have been developed optimization algorithm for adding for one single train for yard. And at low, we have been working with yard delay model and machine learning of wagons and trains in Malmö, and that is work in progress, but we have reported this work in deliverable 3.3, chapter 3. Next, please. So this is a result from the DLR work of the corridor when we increase timetable speed to 160 kilometers an hour for freight trains, or the freight train speed to 160 kilometers. And this study, the conclusion of this is to get effect of this, we need to do different prioritization, and also to work with the timetables, and also giving priority, for example, freight versus slower regional passenger traffic in conflict situations. Next, please. In this operation scenario, we had also this freight trains with 160 kilometers an hour, but we had it just needed in particular situations. So we just allowed them to have this higher speed when it was needed. And when we had this operation scenario, then we could see quite a positive impact. And we can use this positive impact by improving the quality, or to add extra trains. And our estimation is then 2 extra trains per hour and direction. Next, please. This slide shows the work of KTH, where they have developed this 2-step algorithm, first with optimization of an initial timetable with rescheduling of many freight trains, and then also doing scheduled the predicted delay. So it's a 2-step. And for this, there is also a video if you are interested to see more information. We don't have time for it now, but it is a video there you can look at. Next, please. This slide shows our report. So it's the 3.3, the final report, and then KTH licenses dissertation, and then the DLR parts, and then also common research paper from Optiard and Freight Hub together. And if you're looking to other projects, it's also a link to the results from Optiard, and there you can see video and simulation of software of yards in Italy and in Czech. And then there's some other also link about this current work that I've given some information about, and also to research we are doing in Sweden. I think that was the last one, Anna.
Okay, thank you, Magnus, for the very interesting overview of the work done within the network and management. And I think we have time for a question from Magnus. Anders, do you have a question for him?
Yes, hello, Magnus. I'm interested in the effects as always. And my question is, if you look at the network management and consider it that in the future you can have connected it with the yards and the terminals, and also connected to the trains, what effects can you see in the future?
I am quite optimistic, and I see three main positive impacts. And the first, I would say, is improved system punctuality. And that is better punctuality both for freight trains and for passenger trains. And that gives us also the indirect possibilities to run more freight trains. That's the first impact. The second impact, I would say, is this with more efficient rail freight transport, and also this possibility to have more efficient use in yards and terminals. So that's another positive impact. And then the third, I would say, positive impact is this with improved possibilities to handle disturbances in the network, and that especially is this with the contact infra manager and railway undertaking, but also this, as we have shown, this contact between a network and yards and the terminals. So three main positive impacts.
Okay, thank you, Magnus. And as we have some time in the end and all the presentations are done, have time for some more questions from the audience, all the panelists. And
Yes.
Anders.
Yes, I have at least two questions I can ask that has come in. And one is you have to call to Andrea Masonek. If you can hear us, you can connect with unmute your phone or something.
Yes, I can hear you.
Fine.
Do you hear me?
We have a question to you. So I will read it and say hello to your kids.
Yeah, hello to my kids.
Yeah. The question
I just closed the door. Sorry for that.
No problem. The question is about the expected impact on 23% of the reduction with the subsystems that you have evaluated. Can you comment more and tell us more about that?
Yeah, sure. I've seen a question. I mean, yeah, the 23% are compared to a diesel locomotive. So we were looking at, in that case, it's about hybridizing Larger shunting locomotives, so not the small ones, more a mix between a mainline locomotive and a shunting locomotive. And they run usually with diesel today. And by hybridizing those and by integrating lithium-ion batteries, because we were looking mainly at lithium-ion batteries in this case, and doing, of course, simulations and with respect to energy consumption, using real load cycles, we have seen that we can save up to 23, but even more. I mean, it really depends on how old, to what kind of locomotive you're comparing. There are really old diesel locomotives, and there you can save up to 30%. With the newest diesel locomotives, the difference is not that much. You may be able to save 10, 15%, and then it also depends on the use case itself. Are you talking only about last mile, or are you talking about, traveling over a larger or a bigger distance on electric power only?
Okay.
Does this answer the question?
Yeah, I think so. Otherwise, they have to write to you directly.
Yeah, sure. It's welcome. Just drop me an email.
I have another question, and it's for you, Norbert, if you can unmute yourself. And it's about why is the sustainability excluded from the CBM analysis?
Yes, so I've seen the question. So my question here would be, sustainability has many meanings. I guess the meaning is here environmental reasons, because that's one of the meanings. It could also be long lasting with no negative turnaround. So definitely, if we save materials because we replace our components less often, then that in turn also means less waste. So there you have an environmental impact right away. I wish the colleague who asked the question could be a bit more specific, though, in which regard sustainability should work out. Do we have a clarification maybe in the chat, or? Oh, okay, yeah. I just read it. Sustainability has 3 pillars. Yes. So that's an interesting point. When we talk about life cycle cost, we usually talk about RAM LCC. RAM's LCC remainability, which includes also the maintainability, and sustainability could be a part of that. I just see Zach Kanrunen answered environmental, societal, economical. Yes, economical is the driver. If we look at our LCC target, societal, not so much, to be honest. Environmental could also be a driver. We haven't measured with regards to springs. We haven't measured what the impact is on waste and waste materials, because this is pure steel component. But overall,
if I may, Norbert,
yes.
Hello, this is Manuel. I think you're completely right, but I would like to complement this thing, because the CVM strategy is trying to optimize the life cycle cost. So basically, we are going to be able to rotate the asset longer years. So longer years means having much more sustainable from the environmental point of view, from the societal and economical. Environmental, because it's going to work better, it's going to be less polluted, and it's going to be best looked after, especially for railways where noise is something which is polluting. So we're going to be very much careful regarding our noise impact, and it's going to be better catered for. Especially, I'm going to give you a very precise element with brake pads. So that's a kind of consumable that freight trains use. And with our CVM program, we're going to be able to check status and going to be much more accurate with the status and deliver a better environmental impact. Economical, of course, it's a matter of optimizing the asset and the way we are rotating that asset. And so societal, I think we're going to contribute to the circular economy because we are going to reduce the number of waste, because we're going to be much more optimized regarding spare parts. So things don't get changed because we feel like it's going to be changed. It's going to be changed because we've got the necessity for changing it. So we are going to really make a major impact in these 3 points. So I think, although it is very much driven from the engineering point of view of RCC and the RAMs and the 5126, of course, we've got these 3 impacts. I've just given you an example. Brake pads, environmental, I'm sure it's going to be better catered for, and therefore noise impact is going to improve. Economical, of course, and societal, of course, we're going to be much present in this circular economy. We're going to reduce the waste, and we're going to make the best out of the assets we've got. Thank you, Norbert.
Thank you, Manuel. Thank you. Yeah.
Okay. Thank you, Manuel, and thank you, Norbert, for the answers. And I think that were all the questions, and I will leave Jan to summarize this session.
Yes, thank you, Anna. Yes, that's my duty and honor to do that. Thank you, everyone out there listening in the late hours here for freight on freight issues. It's important, as you know. If we should really be able to fulfill the Green Deal, I think rail plays a very important role. I stated in the beginning that we have to work more with migration and combine innovations. We have to work with the possibilities. And I think I feel more comfortable after this day that we are combining, that we are looking into innovations on IP5 level as well as in Freight Hub, which now goes to the final. And that's good. That's good, because then we can fulfill what Jürgen started with, the market needs, and we can conclude it with a couple of presentations with a systematical approach. And having said that, please also remember that innovation is important. There is problems out there, but now, if the Green Deal makes the end customers interested and the shippers interested in rail, we can't bring along problems. We can only bring along solutions, and innovation is one part of that. There is also other. Everything is not innovation, so there is also some quick wins, so to speak. Let's do it, and let's keep up the good spirit. And thank you once again, speakers, audience, and everyone for joining us. And you will hear much more from the freight guys in the future, I'm sure. Thank you, and have a nice evening.